Hi, friends. Today we're going to go over some of the Punnett Square questions, and this is the sheet we're going to go over. It was from Friday, the 8th of January. I just want to make sure that we hit the date right, and you can see the sheet because I'm going to kind of pull away and go to actually doing the problems. And so I'm only going to do a couple of the questions. I'm not going to do all of them, but I want to make sure that we feel comfortable with this idea of traditional Mendelian or basic Mendelian inheritance, and that we feel like we got it. Okay, so let me stop presenting here, and then you guys can see my screen. So the first question is actually one of the probabilities ones up top. This is actually one that it was a struggle in class the other day, so I want to make sure we got it. So question 3. Does what type of gametes would be produced by an organism having the genotype big A, little a, big B for 2 traits? So we'll say we have big A, little a, big B, big B. Now, when we talked about meiosis, we talked about how meiosis is going to, this is a diploid number of traits right here. So this is 4. That means each sperm needs 2. Okay. Each sperm needs 2, or egg needs 2, and you need 1 of each. So it says use arrows, and what that means is the arrow technique is kind of as simple as just using arrows here. So we're going to have a big A go this way. Like we talked about before, every time you split up a diploid, you get 4. So we're going to have 4 arrows. So 2 from there, and then 2 from this little a. So we have little a, big A. And the same thing for big B. If I draw the arrows again, the big A, big B, big A, big B. And then we end up with those. So that's actually the possibilities. So it's 50% in the sperm or eggs, big A, big B, and 50% little a. Sorry, my pen's dying on me here. Little a, big B. Don't you hate pens? Sometimes pens just never work. Awesome. Let's move to the next one. Let's do number 3. Number 3 in another section is albinism is a recessive disease causing lack of pigment. So this causes someone to be albino. What are the chances of an albino man and a carrier woman having an albino child? Show the Punnett Square and give answers as percentages. So this is question 3 as well. We'll say A. So big A equals normal. We don't really like using the word normal anymore because what actually is normal, but we're going to just use it in this case. And then albino is little a. Cool. And then it says the man is albino, so he's going to be little a. And he's crossing with a girl that is a carrier. We haven't really talked about this term carrier. But what it is referring to is she doesn't have the trait, or she doesn't show the trait, but she's carrying the possibility of giving it to an offspring. So she's heterozygous. So when you see the word carrier, it means someone that's heterozygous. If I actually do the Punnett Square, little a, big A, little a, we find out that, oh my goodness, this pen. Let's see if I can find another pen. Give me a second. I'll just use a pencil. Lily. Okay. So I have 50% big A, little a, 50% little a. I also need to do the phenotype, 50% normal, 50% albino. All right, let's do another question. Number 1. In summer squash, white fruit color is dominant, big W, and yellow is recessive, little w. Squash plant that is homozygous for white, big W, is crossed with a homozygous yellow one, little w, little w. Due to Punnett square, the predicted phenotypes of F1 and F2. Remember, you cross two F1s to get the F2 generation. So, number one, I have big W, if I put up here what it means, white, little w equals yellow. Sometimes with these kind of letters, I like to put like a little mark in them to reference what is the small one, what it isn't, because like my W's all look kind of the same. Yeah. Awesome. And then we're going to do the Punnett square. We find out they should all become big W, little w. So 100% big W, little w, 100% white. Now this is the F1 generation. These are the F1s. So we're going to take two of those and reproduce them to get F2. So big W, little w, big W, little w. And we go through and we find out the F2 generation is going to look a lot different. We're going to get 25% big W, 50% big W, little w, 25% little w.
Good morning.
Good morning. And then we're going to do the phenotype, sorry. 75% white and 25% yellow. All right, so those are the three questions. So we did number 3 up top. Well, you guys can't even see it. I'm so sorry. Should have said something, guys. Sorry. Let me go back through it. So this is the F1. My bad. F1 here. Okay. Get big W, little W's. Here's the big W, little W F2 generation getting made. Well, F1's making F2s right here. This is the genotype. This is the phenotype. Sorry about that. I thought I wasn't paying attention on my screen. So we have 3, 3, and 1. If you need help with any other questions, you're stuck or anything like that, just let me know and I'll go through it with you. And we'll try our best to make sure we understand it. So if you need more help, let me know. Thanks, guys.